Hello and welcome to the 619th VJEG session. This is going to be a fun session from our speakers today. Let's introduce them. We have Raul on the left of your screen now. Hi Raul, how are you doing?
Hey Sam, I'm doing great. Thanks for having us.
Excellent, no problem. And Richard Warburton on the right. How are you, Richard?
Great, good stuff.
Excellent. Well, welcome back, Virtual Jug. This is your second appearance.
You missed it.
The first appearance was refactoring functional programs.
Functional refactoring in Java.
That's right. Yeah. Awesome, cool.
Yeah.
And so today you're going to be talking about this new thing that's just appeared in Java called Regenexx, right?
Yeah. Well, generics, past, present, and future. We'll be going way back, and then looking at how people use it or don't use it, and what's coming up.
Awesome. Well, I think it's going to be fun because everyone uses generics. Everyone has a different understanding of generics within a team, I think. So it's good to bring everyone up to the same level. So it's going to be a great session. And of course, Oleg is with us. Hi, Oleg. How are you doing?
Hi, people. I'm doing great. Pretty excited.
And you've been working super hard recently on a report, right?
Yeah. So at Rebel Labs, we are doing those magnificent, beautiful-looking reports on technical topics. So the next one going out next week is about Android as a platform, since it's kind of like very similar to Java ecosystem. So been typing furiously. You can see it's got interactive. Really excited about this report. Go read it when it appears. I'm super pumped to see you people in the session.
Cool. So generics, past, present, and future. Our speakers today: Richard Warburton and Raul Gabriel Lerma. We didn't actually have space to put the Twitter handles, but I'll pop them into IRC just shortly. In fact, Oleg, why don't you do that right now? The session is sponsored, or the Virtual Jug is sponsored by Zero Turnaround and media partner of Rebel Labs. Zero Turnaround provide revolutionary developer tools, so do check out JRebel for your instant code reloading, and XRebel your lightweight Java profiler at development time. And there's also some free tools that Zero Turnaround provide, including how you can speed up your Eclipse environment using a tool called Optimizer for Eclipse. So do check that out, zeroturnaround.com for some of the free trials and the free tools as well. So the Virtual Jug, we've just passed 4,500 members, so that's a really cool. A really cool milestone for us. So let's continue. We're hopefully going to hit around 5,000 by the end of the year, which is going to be super cool. Any questions on today's session? Ping us on IRC. If you're at virtualjug.com, you'll see the IRC widget right next to your YouTube window. Pound or hash virtual jug is where you can ask questions and start discussion, and I'll ask the questions directly to Richard and Raul. Please do share the group session. It's your sharing and your kindness which is helping the group to helping the community to grow and progress. So please do share that. In fact, while you're at your laptop now, why not tweet the link and show everyone that you're learning about generics, and everyone should as well. And as ever, if you have feedback at Virtual Jug or at SJ Maple, you can give me feedback, whether it's about this session or in general about the Virtual Jug. On the bottom right hand side of the YouTube window, there's a little cog. If you're worried at any point about the video quality, you can hit that cog and change your resolution up to pretty much whatever your broadband or your internets, interwebs, intertubes will allow. So without further ado, let's switch straight over to Richard and Raul, and let's start the session on generics.
Cool.
So we're going to share a screen.
Sure.
All right, so there we go.
Can you all see the slides?
Yeah,
yes.
I can see it.
Fantastic. Yeah. So, generics, past, present, and future. I'm sure many of you have hit this kind of situation where you've been looking through either your own code base or a public API or something, and you've basically hit this kind of situation where you see something, and it's sitting there right in front of you, and you don't know, A, what it's doing, or B, what it's there for, or C, how the heck did it get there? What is that doing? Why are you there in the middle of the screen? And I think that applies both to real-life situations and also to generic type signatures as well. You kind of see that a lot when you see this kind of complicated generic signatures, a lot of that kind of stuff. And hopefully this talk is going to be a very, very simple, brief way of addressing some of those kind of open questions of why would I possibly use any of this stuff? What's some of it good for? What are the motivating scenarios? There are basically three parts. Firstly, we're going to go way back into the past and say, how did generics come about in the first place? What was the problem we're trying to solve? Just remind us of that and the context in which generics exist. Then we're going to have a look at the present, where we see that there's a lot of interesting features of generics, but they don't often get used very much. And a lot of the reason is that people don't necessarily know why they would use them, and so we're going to answer that kind of why question, that motivational question. And then we're going to talk a little bit about the future. We're going to have a look at what some of the upcoming changes in Java might be in terms of the type system and how those can influence generics and change them. Possibly for better, possibly for worse, but either way, changing things.
So Richard, speaking of past, present, future, isn't it a special year for Java?
Yes, it is a special year. It's a great year to be doing a look back in time talks as the 20th anniversary this year of Java. So that's fantastic.
So we can't see you guys from the screens, but let's all say happy birthday so we can all hear you for Java.
3, 2, 1. Happy birthday. Fantastic. Thanks. At least I was listening. Cool. Yeah, anniversary. But after that, about 10 years later, way back in 2004, remember 2004? There was the Facebook. The Facebook was fantastic before it got renamed. Had some great developer aesthetics. Look at these square brackets here. This is what you need to get high UX, developer UX, square brackets, binary numbers, zeros and ones. Awesome. The Facebook. But what else was happening in 2004, Raoul?
The introduction of generics in Java.
Yes, exactly. Generics added to Java. This is great news. So, what was Java like pre-generics? What was vintage Java looking like? Well, we turn over to our IDE. We had code like this. There was no generics. It was nice and simple. We took a list. We added we added some values in. We loop over our list and we run them. And what happens when we run this code?
No, Richard, you're adding strings and numbers in the same list?
Yeah. And what happens is we get a class cast exception because we're taking the value out as we iterate over them, we're casting them to a string before we print it out, and we've got both strings and numbers in there. So we print out a couple of strings, and then we get a number. What generics enabled us to do was express this problem in a more safe manner.
But
so I
Richard,
could say...
Hold on. What would you define the next to class? One called list integer, one called list string. This way you can ensure type safety, right? That's the problem you're trying to solve.
Excellent. So one option would have been was instead of having a list, we could have said, hey, let's have a string list, and let's have a string array list, and let's have an int list and an int array list. It's fine. We don't work for Sun or Oracle. We don't have to maintain this code. They can just keep on adding more and more of them. But obviously this kind of solution isn't really tractable in a general case because it means you need to have a new implementation every time. So that approach would have allowed us to stop this error, but wouldn't have really been maintainable or a general solution to the problem. So the other approach was the addition of generics. So we can say, make me a list that only contains strings, and our runtime error is magically transformed into a compile time error. You can only add strings, but you're trying to add an int. That's not okay. So that was the basic context.
Fantastic. Sounds like this new abstraction here lets you have both type safety as well as avoiding code duplication.
Yes. And one of the other things that happened over time, also to avoid code duplication, was to begin with, we had to say it was an array list of strings, and then in Java 7, the so-called diamond operator was introduced that meant we could be less verbose. So nice and simple, list of string is new array list, and it now compiles, but it wouldn't compile if we tried to add the 1, so we're safe. In fact, we like to think of there as actually being kind of trilemma in terms of features here. So one end of the spectrum, is the choice that Java made, and Scala and C# and C++, and that's to add generics to the language. By the way, this trilemma, I'm not saying things are concise or simple or safe on a context-free basis. I'm just talking about generics, just talking about type parameters here. Another approach is the approach of having either a string list, so a special class for just a few cases that makes it type safe, or for example, some programming languages have a few built-in types which are generic, like Phantom, but no general generics.
So it was actually 3 built-in types for generics, only
3.
Map, function, and list.
Fantastic. 640 kilobytes of RAM is enough for everyone. So and that's quite good because it means we have static safety and simplicity. But you know, it's not very concise because anytime someone wants to have a custom type, they want to have a tree or some database library that needs to be generic. Every time one of those libraries needs to be written, it's not very friendly because they don't have that generics feature. Another option is the dynamically typed world. So those guys have simplicity because there's no generics, it's nice and simple. They have concision because they don't need to have this boilerplate rewrite every time. But they don't have static safety. Those runtime errors still happen at runtime. And then there's the Java, Scala, C#, C++ world, which have the static safety and don't have this boilerplate multiple class writing, but they don't have simplicity. Generics are not a simple topic. I think as we go through and we talk about some of the features here, it's always worth bearing that context in mind because, there's value that we're giving. The context is the static safety plus concision combination.
It's worth saying that if we look at the programming language landscape, a lot of those languages, such as dynamic type like Ruby and Python, are all going down the route of static safety, adding an increasingly rich type systems. And the trade-off, which we'll revisit later on with Java, is actually it becoming more and more complex for us users of the language.
Yeah. Cool, but 2004 was a long time ago. What's happened since then? What about generics usage today?
So we're going to look at 3 patterns of generics which you may or may not be familiar with, which we found interesting. One of them is called intersection types. The other one has this really fancy name which you can bring up during fancy dinners called curiously recurring generics pattern. Don't we just love those kinds of names?
Terminology, lovely, lovely.
And finally, everyone's favorite feature, undeniably, wildcards. We can't see you guys, but I'm sure you're all loving wildcards. So we're going to start with intersection types. And really, in intersection type, we need to look back at those Venn diagrams which we did in primary school. Don't we just all love how pretty they are? But the basic idea with Venn diagram is that you can get an intersection region between 2 circles. Right? So this area in the middle here will be the intersection between A and B. So an intersection type is lifting this idea here from maths and from drawing to programming languages. So if you take an intersection type in Java, it looks as follows. By saying t extend A, we just say that the type parameter t needs to be a subtype of A. But if you use an intersection type using the ampersand operator here, you're saying that t is a subtype of both A and B. So it's really the region in the middle here if you think of those 2 circles as 2 types. Okay?
So at any point in time in this talk, when we say subtype, what we really mean is the thing on the left either implements the thing on the right if the thing on the right is an interface, or it extends the thing on the right if the thing on the right is a class.
Fantastic. So is this feature useful? Well, let's look at an example. So this example, essentially what we want to do is to be able to deserialize some information from a file. So we're going to have a file here that contains information about persons, and we'd like to deserialize this information. We've got a read method here, which is going to take this data input stream, and it's going to generate a person object. So if you look at person, it's essentially a wrapper for a name and an age. Okay? So let's just run this file here to see what happens. Fantastic. So we get Richard's favorite Don Draper.
89, that show was a long time ago. He's a very old guy now. Mad Men may be over, but it's still a great show.
Fantastic.
That's the main takeaway. Watch Mad Men.
That's the main takeaway of this webinar, guys. So let's look at how read is implemented. So it takes a data input stream. Fantastic. we're going to try and read some information from this input. So we're going to try and read the name for the person and the age of the person. And with that in hand, we're going to produce a person object. So far, so good, Richard?
Looks lovely, looks lovely. But what happens if we need to change the input to be something other than a data input stream? Maybe we've got a random access file, and we want to use that as our data input source. Can we do that?
Well, let's give it a go. So instead of using a data input stream, we like to use a random access file. Unfortunately, we get a compile error. And why do we get a compile error? That's because the read method here is expecting a data input stream. And random access file is not a subtype of data input stream. There's no relationship between those two. So this is a compile error. But it's slightly unfortunate, Richard, isn't it? Because they're doing similar things, aren't they?
Yeah, I mean, they've actually got all the same methods on here. We're in the body of our read method, we're using the close method because we're using try with resources, and we're calling read UTF and read int, and random access has got all those things on.
Precisely. So let's dig a little bit through the data input stream and random access file to see if they've got interfaces in common, just like Richard just mentioned. So if I dig into the data input stream, you can see it's implementing a data input interface. The next thing that we can look at is, okay, it seems like it's extending file filter input stream, which itself is extending input stream, which itself is closable. Okay, so they've got a closable and data input property. Investigate a little bit how random access file is defined. We'll find that actually it's also implementing closable, and it's also implementing the data input interface. So this is a bit the middle area in a Venn diagram. Data input and closable are the two things that the data input stream and the random access file have got in common. So now one approach potentially, Richard, would be to say, why don't I define a data input closable interface which extends data input and closable? Would that be acceptable?
Well, it would solve your problem in terms of giving a common type, but you don't own random access file or data input streams. You can't retrofit those to have that interface, can you?
Indeed. I'm trying to refactor the read method to make use of this interface. Unfortunately, random access file and data input stream belong to the JDK library, and I can't retrofit this interface to that. So we need a new trick, isn't it?
Yeah.
And that new trick is intersection types. So you can define a new type parameter, AI, and this type parameter here is going to say that it's sending both the data input and closable. We've created sort of dummy type here that we can use, which is the middle region in our Venn diagram, by saying, actually, this is what the random access file and data input stream have got in common. So I can use this type now inside the signature of the method as well as its in body. So the input will be of type I, which is data input and closable. We refactor the method accordingly, and now we get compilation. So let's run and see what happens. Fantastic. Now we get the right behavior. So if you see yourself in a situation where you need to create a sort of dummy type, but you're unable to retrofit an interface into an existing library, for example, such as in this example, the JDK library, this is a scenario where intersection types can be useful. Otherwise, in practice, we still recommend using an interface because the name is meaningful. But in this scenario, we couldn't retrofit that interface. So there are other possible scenarios for using intersection types, Richard?
Yeah. Here's another one of those situations where you look at the code and go, what the heck's it doing? What the heck's it? Why is that there? What's it doing there? This is actually the signature for the max method, collections.max, that takes a collection and returns its maximum value. So why does it have to be so complicated?
Yeah, it doesn't make a lot of sense because comparable is a subtype of object already, isn't it? It's a comparable object. But more importantly, why is Simon's door in this slide? Simon,
I don't know.
You really need to fix this door. So
this is a very confusing type here because it says T extends object and comparable of question mark super T. So don't worry about the question mark super, we'll explain that a bit later. But we've got a situation here where we're saying we want our generic type to be something that's comparable. Everything that's comparable is already an object. So why does it have to extend the intersection of object and comparable?
So to answer this question, Richard, we need to look at how the code was designed before Regenexx. So before Regenexx, this used to be the signature for Max. It says, I'm taking a collection of objects, and I'm going to return you an object, which is the maximum. So that seems pretty reasonable. Unfortunately, there's something missing here, isn't it? To be able to find a maximum, you really need to be able to compare those objects. So that's something that's missing from this signature. But unfortunately, once you've got a method signature to preserve binary compatibility in Java, you're stuck with this signature forever. So any new signature that we come up with in the future needs to be able to compile down to the same signature. And that's really the problem that we're going to explain. So arguably, this was a design mistake, and potentially this should have been returning a comparable object instead. But that's besides the point. So let's look at where intersection type fit in. So by adding comparable, essentially what you'd have, so if we forget about the object intersection type, if we just say here we've got a collections of elements T's, and T's have to be comparable. If you compile that, you get the following signature, because generics are raised by the Java compiler. So you get a different signature to the one we had in the past. So that would break binary compatibility. To fix this issue, again, we need to come with a trick. In this case, the trick is to introduce intersection types. By declaring that the left-hand side of the intersection type is an object, this is the type that will get picked up during the Java compilation and will produce the same signature that we had pre-Regenexx, and we preserve binary compatibility. So we've got a happy smiley. So the interesting trade-off here is that we've actually added more complexity in a public API signature to preserve compatibility. And that's Java's philosophy, preserve binary compatibility.
Now, I'm sure a few of you guys have started adopting Java 8 and using lambdas. One of the interesting things about lambdas is the type of the lambda expression is inferred as being the context in which the lambda is used. And what that means here is we've got a function that's building us a comparator. And what it does is it says, take some value, pull out the keys from both sides using this extractor function, and compare on those keys. So, you know, say compare a person by name, nice and simple. Now, by default, you might just want to have this to return a comparator of T, where T is the type of things it's going to be comparing. But there is also a desire for certain of these lambda expressions which get returned to also be serializable. But there's no way that comparator can be retrofitted to extend the serializable interface, and you probably don't want to do that either. You don't want to require that every comparator has to be serializable. So consequently, there's a cast to an intersection type used as the return of this method here. And what that does is it says, you know, this thing's a comparator, but I want it to actually be the intersection between comparator and serializable. This is still an interface with a single abstract method, which is what lambda expressions need, because serializable has no methods on it. But what this means is it's like telling Java C, look, just go generate me the serializable gubbins for lambdas, just go do it. And that's also kind of quite interesting usage of generics, of intersection types, I should say. The ability to generate serializable lambdas, even when the functional interface doesn't have to be serializable.
Fantastic. So that's it for intersection types. We're going to now look at another pattern called the
curiously recurring generics pattern. So I'm sure, you know, many of you guys, again, what's this doing here? Why is it there?
I think that's Oleg's door now.
That's Oleg's door. What's up with these guys' doors? the most common place you might have seen this is within enums. You might see enum of E extends enum of E. So the type is recursive. It references itself back. So why would you ever do that? Well, again, let's turn and take a look at some code. Ooh. We've got a method here, and this method has two confused people in. One's called John, one's called Bob.
We apologize for all the John and Bob listening to us right now.
It's only these John and Bob instances that are confused. Not every John and Bob instance is confused. So why is John confused? Well, John's got a method on here called clone, but if you clone John, it doesn't return a confused person one.
Why does it return a string, Richard? Surely it should be returning confused person.
I have no idea. But, you know, it's a reasonable thing. If you want to clone somebody, you want to get back what you've cloned. Assuming you could clone people. And another person, working on it, another person is confused person 2, Bob. Now, Bob is not that confused. If you clone a Bob, you get a Bob. And if you clone a Bob again, you get a Bob again. But the problem is, if you want to clone someone twice, that's the kind of thing you might want to abstract over. So, what about if we instead saying confused person 2 and call clone twice on confused person 2, call clonable question mark and say, hey, we'll just write a generic double clone method. It should return something that's clonable. If you clone something, that thing should in turn be clonable.
So it sounds like we're trying to say that clonables should be able to know that they have to clone themselves again.
Yes,
right?
Exactly. But unfortunately, you get a compile error there, okay? Because the clone returns an object and doesn't know what to do.
How do we fix it, Richard?
How do we fix it? Well, let's go and see what's wrong with John. So John is clonable of string.
That should be picked up as a compilation error, Richard.
It should be picked up as a compilation error. So let's have a look at the clonable interface.
Oh.
Clonable is just clonable of T. What we really want to say is that anything that's clonable is also clonable. So clonable of T extends clonable of T.
Fantastic. So we're using the extends here to specify constraint on this type parameter T.
Exactly. And what that means is clonable of string is now an error. That person has to be clonable of confused person 1. And their clone method needs to return a confused person 1. That means its body needs to instantiate a confused person 1. Great.
So if we look at this code, so we've got confused person 1, which is passed as the argument to clonable. So that's going to be the T, the type parameter T. And itself, confused person 1 is explicit saying it's actually implementing clonable of itself, which matches the thing to the clonable interface.
And if we head back to our main method, we see also that the compile error on our double clone method has mysteriously disappeared. Well, what's going on here? Well, now you clone someone, and you know what's returned is clonable. So if we run this, we can see that we're printing out John's clone and Bob's clone's clone on the command line. So that's fantastic. Everyone's cloned, and possibly multiple times. No evil science fiction can result as an end result of the curiously recurring generics pattern.
So this is the meme that sort of encapsulates this idea?
Yep. You'd argue put a type parameter in your type parameter so you could clone your clones.
All right, so now we're going to look at this third pattern, which we all love, wildcards, question mark.
Question marks everywhere.
I think there's a reason why they decided to use question mark for this feature. It's confusing people.
It does confuse people.
So let's look at what we can do with them. So you know, again, we've got some examples pulled out of the JDK library here. We've got some simple ones, like the unmodifiable list here, question mark extends. Well, that could be reasonable. But Richard, what's this about? What's this super T? Why do we have question mark extends and not a question mark super? What is going on?
There's quite a few question marks there, isn't there?
Yeah.
What is going on, Raoul? I've no idea what's going on. Let me in on the secret.
The secret is subtyping.
Subtyping.
So what is subtyping? Let's review a little bit what subtyping is about and how we can extend it to Generics. And this is where wildcards come in again. Fantastic. So here we're going to use a domain with messages. So we have an abstract class here that represents a message, which essentially is just a wrapper around some content. We may have different kinds of messages. We've got an email message, which extends that class. And we have also text message, which extends that class as well. Okay. So, Richard, what's the first thing that we'd like to do?
Well, suppose we want to actually send this message, or for the sake of argument, let's just log it. Let's print it out on the command line. So we'll log an individual message, or, you know, any old type of message, right? That's going to work, isn't it?
So we're passing a text message as an argument to log, but log is expecting a message, though, as its declared type. This is possible because text message is a subtype of message, and that's done in Java through the extends relationship and through the implements relationship with interfaces as well. That's
nice and simple.
Nice and simple. Richard, could we do something with arrays potentially?
Yeah, I think we have a log array message. So why don't we create an array of text messages and instantiate them up and pass that into the log array. VJug, glorious.
Glorious.
And then if we run log all, it takes that array of messages. And if we run this code, you'll see that we have both the original hello message and this array, this hi VJug. Oh, that's cool. That's really convenient. That's nice and flexible. It means we can pass in an array of text messages where we get an array of log all. I presume that means you can assign them as well, right?
Yeah. Well, let's try it out, Richard. There's only one way to find out. So here we're going to say messages, message array, and we're going to assign those text messages. Looks like we're able to do this assignment as well.
Nice, nice.
So essentially,
hang on a minute, Raoul. Does that not mean that you can assign other types of message into that text message array?
Very sneaky. Very sneaky. So yes, indeed. Since what we've got here is in subtyping, we're saying that a text message array is a subtype of a message array. So I'm using this annotation here to indicate it is a subtype. We had this relationship that a text message is also a subtype of message, which means email message is also a subtype of message. Therefore, we should presumably be able to assign an email message here, Richard. Right?
Yeah, let's do it. Let's
the elements,
the email message.
Let's try out. Hi, London. England, go England. All right. So this seems to be compiling fine, Richard, but it sounds like there's a bit of an issue because the array we've declared here, this array here living on the heap, contains text messages.
Yeah, Raoul, it compiles. Ship it.
Compile, ship it. Let's just run it then, and let's go to the pub. We're not going to the pub anymore, guys. What happens? Well, it looks like we actually broke the type system a little bit. Essentially, message here is the array that we've declared, and we've got the elements available on the heap, so that contain text messages. But now we're getting a different view to this array by saying now the views are messages. So we're trying to modify an array that contains text messages containing email messages. Clearly that's wrong, Richard. Clearly that's wrong. So some argue that this is a hole in Java's type system. Back in the days, pre-Regenexx, if you think about implementing a method that needs to find an item in an array, it kind of makes sense to be able to have an array of objects and the object element that you can find, so you can pass an array of integers, an array of strings.
Mm-hmm. With hindsight, a little bit more difficult to justify.
So, can we do better? Can we get type safety and subtyping, Richard? Well,
what about lists?
All right, let's see how this works.
Screw arrays. It's 2015. Let's use some lists.
Let's use some lists. All right. So got a list of message. We're going to call it list of messages. We try and assign. Have we got another list defined here? Fantastic. We've got a list of text messages. So actually, you know what? Even better, we've got a log all method. So let's just use that right away.
Yeah.
Right? Let's just use this method.
Log all our list of messages.
Wait, why doesn't it work?
Cannot resolve list of text message. Oh.
So it looks like we can't do the same trick that we had with arrays.
Well, that is safe, right? We had this problem with arrays because, you know, we were able to assign a text message array to a message array, and we could then mutate the message array and get a runtime exception. So this is safe.
This is safe, Richard, but it's not very flexible, isn't it? Ideally, we still like to be able to pass a list of text messages to a method that expects a list of message because we're actually not writing to it. So
let's have a look at the log all message method and see if it's safe to do so. Yeah, we're just printing it out. It could be any type of message.
Yeah, we're not adding anything to this list of messages. So we're only viewing it.
Yeah.
So this is a bit too restrictive, and this is where wildcards comes in. Wildcards lets you have subtyping for generics. So it's a way to get both type safety as well as flexibility for your APIs. So ideally, what we like to do is to be able to say, we've got a list of text messages, we should be able to log them. What you can do using wildcards is to do something like that. You say anything that extends message is allowed to be passed in. But what the compiler is going to do for you is ensure that actually you cannot write to this list anymore. Anywhere where the type parameter appears in the right position, you're unable to use it. So you get both type safety and flexibility. So let's run this code just so we are sure that this is all working. So this is not working because we still got our
array store example.
Covariant arrays example here. So let's run this again. Fantastic.
Followed by text.
So this, if you will, is sort of the natural subtyping that we all think about. We've got a list of text messages, should be able to pass it into a list of messages. Fantastic. But Richard, you know, requirement changes these days, you know.
Every day.
Every day, that's our life. So potentially we may want to be able to log those messages in different ways, right?
Yeah, yeah.
So
why don't we use the nice new consumer interface from Java 8. So consumer is a functional interface that takes some value and it returns void. So it's a great thing for something like printing where you just say, hey, pass in a consumer, accept the message in question, and then whatever passes in that consumer decides how they're going to be printed. For the simplicity of this demo, so we're just going to pass in, you know, the standard system out println.
We're going to create a consumer for the message. Okay?
Yep.
Okay. So we're going to say print the message. This code is not compiling yet because log all now expects 2 arguments, so we need to provide this consumer. So let's make use of our favorite lambda expression, shall we?
Yeah. Pull out the message from the message. Lovely.
Lovely.
And then pass in the message.
Right, so let's just run this and see if it still works. Right.
Cool. What if we just print out the message object itself, though?
So you mean you may want to have something a bit more general, right? Something that's not really specific to messages.
Yeah.
Just like our standard good old system.out printout.
Yeah.
All right. Just for the sake of this presentation, I'm going to make it more obvious what's going on. So I'm going to extract that into a variable, and we're going to make use of our favorite method references. What we like to do here is to pass a different way to consume those messages. One that is actually more general, which just prints the object based on the toString method. So let's pass this in.
Ooh, compile error. What's going on here?
Argument found consumer object required consumer of message. But surely, Richard, you know, if I'm able to consume from a message, and I'd like something that is more general. What's wrong with that?
Exactly. If you can print a wrench, you can print a ball.
So what you can do using wildcards is to actually say, we want a consumer of a super type of message. So we introduce wildcard super for that. And what that's going to say is that actually a consumer object suddenly becomes a super type, a subtype of consumer of message. And that might sound a little bit weird, a bit uncomfortable, but this is the behavior that we like to get. We'd like to be able to say, in the context of a consumer of message, we want to pass something that is less specific. And this is where the question mark super comes in.
Compiles. Let's ship it, see what happens.
Ship it.
Wow, and it runs without error as well.
Fantastic.
That's cool.
So that's it for wildcard, guys. The summary is it's all about subtyping. Subtyping lets you have APIs that are more flexible, makes use of polymorphism, and what wildcard does is taking that relationship to Regenexx. So you may see this question mark super in other places. It's commonly used for functional interfaces, such as a comparator. So if you're able to compare a message, then you should be able to have a less specific comparator as well.
Yeah. Same thing with things like predicates. If you can test an email message, you can test any old type of message, right?
Precisely. So it seems like actually all those interfaces here, somehow we should be able to have this subtyping property without specifying it all the time, which it isn't. And that's something we'll look at for the future potentially. So it's always interesting to look at how language features are used in practice. We both like a bit of research now and then. And there's papers that actually look at how language features are used in practice. We recommend reading this one from Chris Parnin. Essentially what this research did is look at 50 million lines of code to find out about usage of Regenexx in practice. There's a big surprise, Richard, that 90% of the users is actually list of string, array list of string, hash map string to string, and set to string. So a little bit like the phantom philosophy, which we explained earlier.
It's okay though, there's 4 types, they only have 3.
We're winning. So I think that's really interesting, that you can get a lot of complexity pushed down the language. But what the user typically do is to actually make use of more simple things. So maybe there's only a niche amount of users that require those complex features.
Or perhaps it's just because those features haven't been explained well enough to people, and hopefully with the, more knowledge about these kind of things, we can get more usage of them. Cool.
So that's it for the present. We're not going to jump in the future.
Yep. The people at Oracle have these, nasty legal slides that say, rah, 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 anything we're talking to you can be a lie. We're just going to put this picture from Back to the Future to demonstrate the same thing, i.e., we're talking about things which are currently in discussion, language features which may or may not be happen. These are just directions which people are thinking. Nothing completely confirmed yet.
So the first thing that we particularly excited about is the idea of use-side variance against declaration-side variance. So there's 2 ways to think about subtyping for Regenexx. The first one, use-side variance, is the one we're familiar with in Java. So if you want to have the subtyping property as a user, you need to explicitly say, well, this list here, I want to make sure I can pass subtype of messages, a list of text messages, for example. So you have to decide as a user that you want to have this additional power. Same thing for the consumer. But sometimes this can feel quite verbose and redundant. In the case of consumer, for example, it doesn't make sense to be able to say question mark extends message. This is just not possible. Same for comparator. So the alternative is called declaration side variance, and this is what other languages such as Scala and C# have adopted. It's pushing the decision of the subtyping property down at the library level instead, rather than at the user level. So this is sort of a syntax that is unofficial in Java. So we've just used it because we're familiar with wildcards now. So potentially we could say that the consumer is always to be used in the concept of question mark super. So we're going to call this contravariant. We always get this property that when you get a consumer of an object, you can pass. When you get a consumer of a message, you can pass a consumer of an object. And potentially we could get the same thing with full streams since we're reading from them. What this means on the user code point of view, you don't have all those verbose annotations that look confusing and scary. You could just say consumer message, but you still get that flexibility. That's something that is really nice. And that's something that Java potentially will be adding in future versions. So there's actually an enhancement proposal being discussed, which you can access at this URL here, which is discussing how such a feature could be implemented in Java, how could we retrofit with existing classes such as compact and consumer. So we encourage you to look at that.
Fantastic.
So Richard, I hear that we're talking Java 8, we're talking with Java 9, but I hear that Java 10 is coming soon as well. It's adding this idea of a value type. So what is it?
Well, very exciting. Their ongoing mantra is the idea of value type is something that codes like a class but works like an int, which is quite brief, but not necessarily doesn't exactly give away what it really does. So the point is that whenever you have an object, you have a bunch of things associated with that object. Specifically, you have identity. If you want to check whether two objects are equal, we can all do the double equals operator. We'll get a reference-based identity. It'll say, are those two objects the exact same object on heap? But oftentimes, you want something that's just a bag of values, right? Just like a struct in C or a C#, for example. And what this means is we have the idea of a type that combines the behavior and value characteristics that something like a class does, but could be laid out in memory in the same way that a primitive does, like an int. So we have no identity on them, but we could still have an equals method. We could still check that they're equal, and that would be a value-based equality. So not are they pointing at the same place in memory, but are they actually the same value? Well, why would you want to do that? Well, the first benefit you might have is the idea of compactness. Objects have headers. Headers have a couple of things in. They've got something called a mark word, which allows you to do locking and bias a lock to a thread and all sorts of things. And they've also got what's known as a class pointer, and that's an internal JVM structure that says this is the class that represents what class they are, as in the class in the JVM implementation itself. And depending upon what your architecture or VM is, these things can eat up to 8 to 16 bytes. So the 16-byte case is on a 64-bit JVM without compressed oops enabled. Objects in Java also tend to be 8-byte aligned. So if you've got a primitive int, you're taking up 4 bytes. If you've got a boxed integer on a 64-bit JVM without compressed oops, you're taking up 24 bytes. That's 6 times as much. The other benefit, and probably the slightly more difficult to understand, but in the long term much more compelling benefit, is sequential locality. So we talked about how it can be more compact in memory, but this means we're talking about it being flatter in memory. Okay? So if you've got an array of objects in Java, what you've really got is an array of pointers. And those pointers all point to some other random location on the heap. So maybe we've got an array of users, that points to a user object. A user object has an ID object associated with it, and a name, name's a string. And what that means is there's a pointer from the array to the user, and a pointer from the user to the ID, and a pointer from the user to the name. So when your program is looping over its array, it has to do this jumping all over the place randomly in memory. And it turns out that's really bad. The reason it's really bad is because CPUs these days run a lot faster than main memory. And in order to reduce the latency involved in transferring data from main memory into the CPU's registers, they have a cache. Caches can prefetch values. They can say, look, I've got here in memory, I think the next thing is the next thing in memory. I'm going to start streaming that in before I even need that data. They can be eager, and it gives us a performance benefit. But if we have these just kind of random pointering directions all over the place in main memory, it's very hard to have that eager prefetching.
So that sounds pretty fantastic. Less memory pressure, better caching, sounds great. And for those who are using Java 8 and been using optional, for example, which is a wrapper around an object, so it has a reference to yet something else in the heap, that sounds like a potential good use case for value types, Richard.
Yeah, exactly. So value types let us inline our fields and say this user just has an ID in and a name in it, and it can all be sequentially inlined, assuming they are value types themselves, of course. So that gives us much better temporal locality, would improve the performance of things like optional.
So how does it work with existing generics? Could we use value types with generics?
Well, the problem is that at the moment, generic types can range over any object. And that means you can do things like make identity-based comparison. You can say t value, instantiate that t, and then say double equals null, for example. You can do things like use synchronized keyword, the built-in locking on a generic type.
Variables.
You can use condition variables, like the way to notify methods that all objects have. Value types wouldn't have those things because they don't have an object header. So there needs to be a way of restricting down the possible types that t can be, and say this is something that we can use with a value type. And there's who knows what the syntax will be, but one way it might look is something like this. We say class ArrayList of any t implements list of t. So what this says is this ArrayList, the contract we're making with you is we're not going to use identity, we're not going to use reference equality, we're not going to lock on these objects, we're not going to call their condition variables. You can put anything in there. It could even be an int. You know how much we've always wanted one of those. That's right. The idea that you could have a list of int numbers being a new array list. And these aren't, a syntactic sugar with boxed integers under the hood. We're talking about having a primitive int array under the hood in this array list.
So I think that's a very interesting story, Richard, because typically what we find with abstraction is that the cost is potential performance. But now here we're trying to merge the two worlds where we get both abstraction and some performance benefit potentially.
Exactly. As I say, these things are all quite a way away, but there's a load of information out there. There's a state of the specialization document, and there's an ongoing project Valhalla which produces binary builds. I'm sure Brian would love it if more of you downloaded those binary builds and tested them out and tried to play around with it and gave feedback on the project mailing list. So, it's really interesting. Go try it out. You can literally just download the binary and play around with it. There's a lot of other language features which, if you're interested in this kind of talk, you might be interested in looking at.
You might want to look at other programming languages, not just Java, if you're interested in maybe more academic type of features such as dependent type and higher counted types, which language like Scala would support. We encourage you to look at it. The Lambda Cube, it's something that's interesting conceptually to look at. If you're interested in the source code for all the example in this talk, I've got the URL here at the bottom of this slide.
Cool. So in conclusion, over time, our usage patterns of certain language features change as others are added. The introduction of lambdas in Java 8 meant that certain generics features like wildcards, which were previously relatively unpopular, became much, much more commonly used, especially in the JDK libraries, but also in end-user code. Generics usage is always going to be on the rise. Libraries are always going to try and want to do more, and libraries are always going to want to be generic. Most of this complexity burden of the increased generics usage and complexity is on library authors, but there's still quite a lot that ends up on everyday developers, so it's always useful to understand this stuff. But most importantly, it's something that kind of runs through a lot of the stuff we've talked about in this talk. The static type safety that generics offer is often a trade-off between simplicity and flexibility and the type safety itself. This trilemma is something that always affects us. And whenever you're sitting there going, oh, why should this not just compile? Why are the generics a pain? It's always bearing in mind it's never going to be perfect. It's always going to be a trade-off. But that's the nature of things. It's now a great time for you guys to start going on IRC, hammering Simon Maple with questions, and we'll come through and answer them in a sec. If you've not already been doing so, I'm sure Simon has some out there. Just before we get on to those questions, I run a bunch of courses on Pluralsight, available at that URL, including a recently released Java generics course, which goes into a lot of this stuff in a lot more detail and covers a lot of other topics. Raoul runs the Cambridge Coding Academy, which is teaching kids how to code, which is fantastic. And also, if you're a professional developer, they also run machine learning courses, which bring you up to date with the latest stuff. Staffed by Cambridge graduates and postgraduates, excellent people. Between us, we run a training company called Iterator Learning, We run Java 8 courses, which we've both written books on that topic, available on the slide. And also, we also run graduate training courses and graduate training workshops. So if you have developers in your company who are looking for kind of a boot camp, get them on board just out of university, want to close the gap to real-world professional development, come and talk to us. Thank you very much. So, Simon, are there any questions?
Absolutely, yeah. Thanks very much, guys. Let me
Start sharing.
Oh wow, it's dark in here. Let me turn the light on.
Hey guys, great.
It got dark. Okay, let's find some questions. We've got some questions that have come in already. First of all, thank you very, very much for a great session. So, question, let me scroll back. A question from Harmeet Singh. What's the difference between the two? List, angle bracket, question mark extends message, and list, open square bracket, T extends message. What's the difference between the two?
So the difference is that the second one, when you say T extends message, you're declaring a new type parameter, which you may use in your class or you may use as part of your generic method, and you're putting a constraint on that type parameter. That's the first thing that the T extends message would do. And in the first example, we have list question mark extends message. You're not defining a type parameter yourself. It could be anything that extends a message. So that's the key difference. That the second option, you're actually creating a new type parameter and giving it a name and calling it T. Whereas with the question mark, you're not declaring any type parameter whatsoever.
Okay, awesome. Another question coming in from JTT Kim. What are the problems and advantages of erasures?
Yeah, good question. So erasure was an implementation technique used to implement generics to begin with. The idea is that you already had a bunch of classes out there that weren't generic, and you wanted a very friendly way to migrate those existing classes and allow them to be generic. So you needed a way of representing a generic type that didn't have any generic parameters, like a raw type. You needed to have a way of referring to existing binary objects that had no generics information associated with them. And what that meant was the implementation strategy is mainly, I should say mainly, not exclusively, but mainly a compile time feature. So some types end up being reified. For example, if you have a concrete subclass of a generic type with a specified concrete generic parameter, like, I don't know, age comparator implements comparator of person, for example, that ends up being a reified type. You'll get a method on there that has the actual person signatures on. But mostly these things are raised, and even when they are reified, you end up with bridge methods. So the problem with the erasure is it leads to lots of situations where you might naturally think you can do something, but you can't, because at runtime there's no generic type information. So an example is the exceptions. Exceptions, you can't have generic exceptions, and the point is you can't say catch a specific generic type because you don't know what that generic type is at runtime. It's been erased. It means you can't reflect as much information as you want. It means you can't say new T. You can't say here's a constructible generic type. And it also means that you can't have, well, until the proposed primitive specialization stuff comes in, you can't have primitives because you don't have a type that's a super type of both a primitive and an object. So you can't specialize method based on the type parameter in a list, for example. A list of integer, we'd all love to be able to sum it, but we just can't. Yeah. So it's one of those things where the pro is basically, it meant generics adoption for even very large legacy code bases was something that you know, is doable and tractable. You know, people sometimes say, well, we've kind of got over that stage, but you know, I had to look at some of the Eclipse internals a couple of years ago, and there were still a bunch of places where they were returning just a raw list interface, and that's the kind of thing where you know, that slow migration that large legacy code bases are going to naturally undertake just wouldn't have been possible without having erasure. But it's a cost we bear in terms of complexity, confusion, and performance from now until the end of time.
Yeah, there's an interesting point that JTG Kim made previously. Actually, let me find it. He or she was saying.
Oh, sorry, I should also say, there's another quite useful pro which people don't really talk about that much, which is there's a bunch of languages, dynamically typed languages on the JVM, which are able to easily use things like Java's collections library because of erasure. They don't know what their types are until runtime, so they couldn't really interact with a properly reified generics very easily, but they can interact quite easily with erased generics. So, you know, JRuby, woo, it's great for them.
So JTT Kim was saying Java generics would be a lot simpler if the erasures nonsense would be gotten rid of. But obviously there's a backwards compatibility issue there. JTT Kim goes on to say, I understand the problem in the bytecode, so backward compatibility issue can be solved by recompiling. A little bit of a wider topic, I guess. But where do you stand on that kind of those kind of changes to the Java language?
He says they can be solved by recompiling. It's true, they could be solved by recompiling if you're willing to have one day when everyone recompiles all of their Java code in every project at once. I'm sure, you know.
I mean, sometimes it's not even possible because you might be relying on libraries already compiled, so
or raw types as well.
You can't just recompile them. So,
I think what he's suggesting is you update all those libraries and then you recompile all of them at the same time.
In an ideal world, we could recompile everything that we all depend on.
Yeah.
In practice,
we're relying on a jar. Yeah.
It's almost one of those niceties that you can rely on Java not doing that, whereas other languages like maybe Scala might do that to their users, but Java is actually quite restrained in that respect.
Free version.
Okay, so no other questions in on IRC. Any questions from Oleg? Let's put Oleg on the spot.
I don't have any. I will be happy to ask all my questions during the interview.
Okay.
Awesome, and that's coming up. That's coming up right next. So just to say thank you very, very much to everyone listening. If anyone wanted to follow Richard Warburton on Twitter, it's Richard Warburto.
Yep.
Was that a restriction?
Their user names are just not long enough for my name.
That's what it was. I always wondered.
That's what the problem was. Yeah.
Okay.
I don't think it's still the case, but that was the case when I signed up.
Okay. and at Raoul, RAOUL UK, all one word to follow Raoul. And I'm desperately typing something just here to show you what we've got on next. Our next session is with Trisha G, or Trisha G. Is it G or G? I always get that wrong.
G, I think.
G. Okay, we'll go Trisha G. Then she can hiss us if we're wrong.
Yes.
Let me share my screen. So our next session is Trisha Jiggy on the 3rd of November, and that's Java 8 in action. So this is quite a code-heavy live demo style, and you can follow Trish, of course, on Twitter at Trisha_G. And this is, I believe, Trisha's 3rd session with the virtual jug, so she'll be hitting a hat trick.
Really good talk as well.
Yeah, it's a good talk. That was at DevOps UK, I think, wasn't it?
Yeah.
And maybe a couple of others as well. So yeah, that'll be in a few weeks then. Before then, I'm sure you can catch up with Raoul and Richard at Java 1.
No, actually, I'm not going to Java 1.
Okay.
Just 3 times consuming. I'll be at, what's my next conference?
DevOps?
There's DevOps Belgium. I'll be at Code Mesh in London about profiling. I'll be at DevOps Belgium about generics. I'll be at QCon San Francisco, also talking about generics and Java language features as well. And LJC conference.
Of course, yeah, looking forward to that. Yes, so do reach out to Raoul and Richard if you have any further questions or want to chat to them or even get on one of their awesome courses. So that'll be awesome. Thanks everyone for attending, and Oleg will of course write up this session, do an interview with Richard and Raoul, and you'll be able to hear more from our speakers in the coming days. Thanks very much, everyone, and see you next time. Bye.
Thank you. Bye.